Back to today's video. So today we are solving the fifth problem of January Code Challenge. So this is the daily challenge series that we are solving, and today's problem is remove duplicates from sorted list 2. So the problem statement goes like this. So given the head of a sorted linked list, delete all the nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So basically we are given a linked list which is already sorted, okay, but there are nodes which are duplicated. So you can see 3 and 3, it's duplicated, right? It's present twice here. 4 and 4 is present twice. So you have to return the linked list which is sorted of the nodes which are present only once. So here 1, 2 and 5 are present only once, so we have to return a linked list of 1, 2 and 5. That's it. Similarly, if you look at this example, 1, 1, 1, it's duplicating. The node 1 is duplicating. Only 2 and 3 is not duplicating. So return the nodes 2 and 3. Okay, and this has to be a perfect linked list. It has to be a complete, like this should be the start node. This should be the end node. Okay, so the problem statement is pretty simple, pretty clear, but we have to understand how we can think about this problem, how we need to solve this, right? And there are some constraints that the number of nodes in this list is 0 to 300, so the maximum length is 300, and the node value can range between -100 to +100. That is, that can be 200 different values. Now the thing is, there are the first approach that comes to my mind. Okay, before discussing my approach, as we already have been doing in our previous videos, let us just take a pause, and if you think you can solve the problem, just pause the video right here and try solving this. If not, let me just continue to the solution. So the first idea that comes to my mind is to use a set. Okay, because we know, like, how do we, let's think about this if it was an array of duplicates. So I'll be using this space for explanation. So let's say we have this array 1, 1, 2, 3, 3, 4. So we can see 3 and 3 is duplicating, 1 and 1 is duplicating, right? So how would I have used a set or a hash map something? Let's say a set is not the right thing. Let's say I would have used a hash map, and in each hash map I would have stored the value of each item, so frequency of each item. So I would have iterated the list first time. I would have taken the note that the value 1 is occurring 2 times, the value 2 is occurring 1 times, the value 3 is occurring 2 times, value 4 is occurring 1 times, right? And once I'm done through this, I'll have to iterate the list once again, and I'll have to create a new list. I'll have to create a new list of the nodes that are present only once. So this one and this one, 2 and 4 would be the answer for this. So I would get a list 2 and 4 because they are occurring only once. So what is the time complexity of this approach? Big O of n, because we are iterating. There is no quadratic iteration, right? It's like we are just traversing the list. But remember, this is a double pass solution. So we are iterating the list twice we are iterating the list. And what is the space complexity? The space complexity is also big of n because of this hash map or any array that you use. You might not even use a hash map. You can create an array, okay, array of let's say whatever values is there, and at each, and you can create a 000 kind of frequency vector, and at each place you can mark the index of what is present there. And the size of this array would be 200 because there are 200 different values, right? 201 different values actually. So that would be constant space, but still this is extra space that we are requiring. Now we'll jump to a solution. We'll think about a solution that does not need any extra space. So that is the approach that we are looking for. That is the approach that the interviewer would be looking for in an interview, because using extra space is an overhead in this solution. So we'll try to optimize this problem and solve it without using any extra space. So how can we do that? The observation here is very important. So observe this problem is very important. So you can see that this, for any, since we know the list is sorted, right? So the repeating duplicate elements will always be in the consecutive positions. So if one is duplicating, I should be able to find one after that only. I there will never be a never there will actually never be a case where one will be here, right? Because it's already sorted. So how many number of ones are present, it will always be followed by this one. So very simple understanding and insight from this problem, that from this concept that we are getting is, since the array is sorted, whatever we have here, whatever value we have here, that consecutive value, if it is same, the next value, the value after it, the node after it, if it is same, having the same value, then this value is duplicating. Then I do not care how many number of ones are present, I should not consider that. So that is the insight we are gathering from this concept. Now, how do we use that? So let us say we use two pointers. Let's say this is the first pointer and this is the second pointer. Okay, I'll just remove this one. Let's say this is the first pointer and this is the second pointer. We see that the first pointer and the second pointer are pointing to the same value, that is 1, and the value is 1, right? Now I will not take them inside my main list. So I'll create a final list, which is the result list. Let us call the result list instead of final list. And this result list will not contain 1. I'll keep on moving this. Oops. I'll keep on moving this until and unless I find a value which is not 1, because I'll not be considering 1. So let us keep on moving this. This is still 1, right? Because see, first is still pointing to 1, so I'll keep on moving this. Now this is the condition when first is not pointing to, my first pointer is not pointing to 1, it is pointing to a different value, 2. Now we see that f and s, the first and the second pointer, are not same. 2 and 3 are different. Okay, so what we can do is we can take 2 into consideration. My result list will contain 2 because I know for sure that 2 is not a duplicate, because the next value of 2 is not same as 2, and the previous value of 2 we have already visited them, so we don't need to worry about that. So we can take 2 into consideration, and 2 is part of our return result list. Next we have, once that is done, we move these two pointers. So these two pointers will continuously keep on moving parallelly. Okay, each of them move by one single place, because we want to maintain one gap, like we want to maintain consecutive, we want to maintain them consecutively. Okay, so now it is 3 and 4. We know that 3 and 4 are same, so, and the value, repeating value is 3. So we'll keep on increasing this until f points to something that is greater than 3, or means not equals to 3. Okay, so we see that 3 value, 3 is same as 3, so we have to move again, but there is no space to move, right? It's null. After this, can we move it here? No, we cannot. What will s point to? Null. It can point to null, but we will not make it point to null. We'll stop here. We'll stop here. So after this iteration, after we are done traversing the list for the first time, we know that until this much, so I'm not considering the last two elements, so until this much, we know we have the result of the entire linked list, right? Until the second last element, till the second last, actually not before the, not including the second last element. So whatever part I have selected here, the result of that part we have here, right? Only 2 is the result from here. And now we have f and s, the first pointer and the second pointer, pointing to the last two nodes. So we can manually check that is f and s same? No, f and s is not same, right? Now now we have to check that if f is same as value, because value has occurred, right? Yes, so do not add, because it's duplicating, because it is duplicating. Is s is same as value? No, s is not same as value, so add. Very simple, right? So we just check this, if f and s is same, If it is not same, then do this. If it is same, then neither of this case occur, because we know these two are repeating. So let's say this one and this one would have been the same thing, then this one would have been yes, f and s would have been same. We don't need to do any of these operations then, any of these two operations then, right? Since they are different, we go inside, we check if f is same as the previously occurring value. Yes, it's same, so that means it's a duplicate node. I will not be adding duplicate nodes, so do not add because it's duplicating. Is s same as the value? Means is s same as the value? If s is not same as the value, technically s should not be same, because if s was same, um, if s was same, f and s are not the same, so technically f is not same. So yes, uh, you have to add s. If s is not same as value, then you have to add it. Yes, or you can just keep it simple. If just check if s is same as value. No, it's not, so add s to final list. And finally we see that 4 is not same as the previously occurring 3, so you add 4, and remember to add a null in the end. Why? Because this is a linked list. Linked list always ends with a null node. So that's the algorithm, guys. I hope this was a pretty good explanation of understanding. If you have not understood how it's working, just go back a bit, because the explanation was pretty simple, and it's very simple how I've explained the video, explained the concept. And if you want to take another example, just take another example and solve it similarly. Just use these two pointers and keep on moving them, okay, parallelly. Keep on moving them consecutively, simultaneously, and keep on checking if they are same. Then you keep on iterating them, keep on moving them until they are not same. And if they are not same, just add the first pointer value. So I hope we have understood the solution now, and let us jump to the code. So I'll be coding in Python, as you guys can see, and the thing is, I'll be first of all, we have to check the corner cases, right? If there is no head, basically if head is null, if head is null or none in Python, we return head, that is none. Okay. If we have only one node in the linked list, what if we have only one node in the linked list? There is no way it can be repeating, right? So if head dot next is equals to none, so there should be two equals. I'm forgetting the basics. Okay, so we'll be returning head. Okay, because we have only single node, so there is empty. I'll be commenting this empty list. This is list with single node, so no duplicate nodes. Correct. Next we'll be taking our f and s pointers, where f points to head and s points to head dot next, as we discussed here, first node and the second node, right? And we'll be taking a dummy pointer. Let's say dummy start. Dummy start is like the starting of the final linked list, so the resultant linked list, or let's call it result start. Okay, so this is the head of the resultant linked list. Actually this is a dummy node, and we'll be considering it just for the sake of easy coding, okay, generalization. And this is the pointer we will be considering at result start. Okay, and duplicate value, that is none. We can take anything, let's say 999, it can also be there. Anything that is not in this range, -100 to 100. So let us take anything, none or 999. And now we'll be starting iterating. So while s is there, so while s dot next, right? Because what we decided, s should not be ending at null, because we have to end at one position before the end of the list. So while second list has not, while the second pointer has not, will never reach the null end of the list. The second pointer should always stop before reaching null. That's why s dot next, while x dot next is not equals to none. This is same as writing while s dot next. Okay, so we'll be checking if f dot value is not equals to s dot value. So this is the case where they are matching, they are not matching. And before that I have to check if s, because s can overshoot, right? So we'll have to check if if s and f dot val is not equals to s dot val. If that is the condition, what should we should just point it to our first node, because we'll be considering the first node in our final list. Okay, so we are not creating any list node. So there is another optimization also we are doing here. So we are not creating a new list, we are just rewiring stuff. Okay, and first equals to first dot next, second equals to second dot next, and ptr equals to ptr. Oops, I made it p. Yes, it's ptr equals to ptr dot next. It's just a pointer. Okay, if it's clear. Now otherwise, what is the other condition? If they are matching, if duplicate node found, if duplicate node is found, then we have to use a, basically we have to keep on iterating, keep on moving the two pointers until and unless we find another node which is different from this one. So how do we keep track of that? We have used duplicate value. So what is the duplicating value? So the duplicating value is f dot val, right? And while f dot val, so we'll just keep on iterating this. So while f dot val is equals to s dot val, so while they are same, okay, no, while f dot val is equals to last duplicate value, we'll just keep on checking if this is equals to duplicate value, and s should not overshoot. So I don't want the second pointer to overshoot, and the first pointer value has to change. Until and unless it changes, I'll keep on moving those two pointers. So f equals to f dot next and s equals to s dot next, right? And that's it. So by the time I am here, I will have the solution of the entire linked list excluding the last two nodes. So for the last two nodes, what do? I just need to check if f dot value is not equals to s dot value, and uh, okay, if f dot value is not equals to s dot value, if basically f dot value is not equals to if it's not equals to the duplicate value as we discussed previously, if it's not equal, so if the last two nodes are not the same, and if the first node is, okay, just let's merge these two conditions together. If f dot value, if the last two nodes are different and the first value is different than the other one, right? If the first value is different than the duplicating value, then we have to consider that. So ptr dot next equals to first, right? If ptr dot next is equals to first, and ptr equals to ptr dot next. Similarly, if f dot value is not equals to s dot value, and s dot value is not equals to duplicate value, we have to point the next node to the second pointer, which is actually the last node of the entire linked list, and we'll just increment the pointer, and remember to add a null at the end of the list. This is just ensuring conditions, okay? Because it might happen that, for example, in this case, for example, mm, let's take an example. Let's say you have a list which we had considered initially, 2 3 3 4. So in this case 4 is the last node, okay? And if 4 comes into our final list, the next pointer of 4 is already null, so this won't be an issue here. But let's say 4 was also duplicating, and okay, let's say 5 is duplicating. Now 4 dot next is not null, but 5 is not a part of our final linked list. So that's why we have to manually ensure that the last node is marked as null. The next of the last node is marked as null to end the linked list. Otherwise, it would be an infinite. Basically, issues would come to end the list. So we'll just denote ptr.next equals to none. That's it. And at the end, we have to return what? This result.start dot next. Why dot next? Because this was a dummy pointer which was pointing, the next of this is pointing to the start of our final linked list. So we'll be returning result start dot next. And let us try running this code. I am hoping this would work, and yes, it worked. So let us try submitting this. Yes, so this solution got accepted, and if you go through this solution, the time complexity of the solution is big of n, because we are iterating the linked list only once. It's a single pass traversal, big of n time complexity, and the space complexity is constant, big of 1. We are not using any extra space, we are just using this variable. We are not using any extra space, right? So this is big of 1 time complexity. So this is the optimal solution to this problem, guys, and I hope you guys understood the solution, and I hope this video helped you understood the solution to this problem and solve this problem. So I hope this channel is helping you guys to comment down below. I love to read your comments and I love to interact with you guys. So if you guys want me to solve a specific problem, also do comment down below. Do like, share and subscribe the channel. That's it for today's video. Thank you so much for watching.